Hello, everyone. This is Tyrannosaurus Luke with Through the Lens of Creation. Today, we are going to be interviewing Dennis Taylor. He just came back from a dinosaur dig site, and he's going to show us what he found and point us to the Bible. So, Dennis?
Yeah, well, thank you, Luke. I'm delighted to be here on your podcast, Through the Lens of Creation. That really describes what we're going to talk about right here. This dinosaur dig event that I attended last week up at the Glendive Dinosaur and Fossil Museum, sponsored by the Institute for Creation Research, which is known as ICR, based in Dallas, Texas. And they had a 4-day event, which you could actually go and participate at the dig site and look for dinosaur bones. And then also sit under the teaching of some of the scientists with ICR, like Dr. Tim Clary. Dr. Clary is a PhD geologist who is the head of research at ICR, and he shared a lot of his wisdom on dinosaurs and fossils and the sedimentary layers throughout this area. Now, the Glendive Museum is up in Montana, over in the eastern side of Montana, in what we call the Hell Creek Formation. There is the Morrison Formation, which is farther to the west. Hell Creek is another dinosaur graveyard area that is more to the eastern side of Montana. And what you find in there is a lot of Tyrannosaurus fossils, a lot of Triceratops. This little guy here is the Triceratops. There's a lot of Triceratops fossil remains, and they even are working on a 90% complete Triceratops skeleton that they're exposing way up on the side of the hill. You can look up from down below on the access road and see a tarp up there where they have that covered. But we didn't go up there. We went to an area where we were digging in layers that were full of small fragments of bones. So these are dinosaurs that just were torn apart and buried, along with clams and other fossils like this, and like this little clam here, this little bivalve kind of a clam that is closed, okay? And when they're found closed like that, that usually means that they were buried rapidly. They didn't open up. They just were buried. And how do you get these marine fossils from way down on the ocean floor, buried alongside of land animals that lived up on the continents like dinosaurs? You know, that doesn't fit the paradigm or the story that's told about this animal fell over beside a stream or in a river delta, and over millions of years was gradually covered up by sediment and buried, and he'll be just eaten by scavengers, and there's nothing left, in a few years. That you don't have millions of years. So fossils are formed rapidly. That's one thing I learned, by a lot of water washing up on the continent and coming down and bringing sediment and covering these animals very fast. Let me share with you, how are we doing with this? Do you have any questions there, Tyrannosaurus?
It is certainly interesting with the clams and everything that they were put under pressure and they didn't open, because usually when a clam, at least is what I know, is that when a clam dies, it opens up.
That's right.
But so it was a lot of little dinosaur bones that you were finding, not big ones, big skeletons?
Yes, right here in the area where we were digging, there were about 20 of us for 2 days, dug about 6 hours a day at this site, and up on the hillside. Let me get a couple pictures here for you. First of all, here I am with Dr. Clary. That's Dr. Clary right there from the Institute of Creation Research, who spoke to us. Now, we went up to the side of the hill, and here you see Dr. Clary investigating a dig site where he's over here, where he's finding a large bone that's just peeking out of the top of the surface and starting to uncover that. So then the whole crew was up at the dig site, and here he's giving us a lecture on the layering and the cross-bedding of the sandstone, which indicates the direction that the water was flowing, and that, in fact, large quantities of water were flowing, covering these animals up there. Now, then we came back to the lab on the last day, and here's a couple shots of us in the lab at the fossil museum, prepping the fossils. We're cleaning them up and sealing them, and that was another day's experience. So what I have in terms of fossils here from the dinosaurs is this large piece, which is, you can see that it's 1, 2, 3, 4, 5 pieces of pretty badly weathered bone that are glued together, and it seems to have fractured longitudinally down through the marrow here, that this would have been rounder on this side. Part of this was shaved off. But from the shape of this and the way it widens up near the top, the experts looked at it and said that could be an upper arm bone from a Tyrannosaurus, or it might be a leg bone from like a Triceratops or something like that. It's a pretty hefty bone. I like to think it's a T-Rex. Okay, so that's just my opinion. Now, here we have some rib fragments. So these little bones in here, you can see the end of this one is shaped like the end of a rib where it was attached to the cartilage there. And these probably went together. They were found close together, but there's pieces missing. That could be a fairly long rib from some kind of a large dinosaur. This one here is probably the best example. This is a vertebrae, pretty well preserved. You can see the surface of the bone where it turns a dark brown when it weathers, and you can see the depression on each end where the marrow wasn't down the center. And you can also see here where the projection that sticks up where the muscles would attach broke off. But right here, clearly you see the canal where the spinal cord was for the animal. So what I'm holding here is part of an animal that died in a graveyard with basically thousands of skeletons of all different kinds of dinosaurs, along with marine life and everything. How did they all get there? And where did all the sediment go then that washed off of there? It had to be a rapid event, a very catastrophic and violent event that killed all life on the planet. And you find these all over the world. So, yeah, the evolutionary story, which is told, would say this is at least 65 million years old. But here's another thing. On fossils like this and bone like this, they are finding soft, pliable tissues inside these bones. And if you go back to 2005, papers were published by Mary Schweitzer and Jack Horner of the University of South Carolina lab, and working up in the Hell Creek Formation, some 30 or 40 miles away from where we were digging, but in that same formation. She found a T-Rex femur, which when they took it to the lab and dissolved it, they found soft, pliable tissue that looked like blood vessels and blood cells and osteocytes, bone cells. And then it turns out that at the Institute for Creation Research and also Answers in Genesis and Creation Ministries International, the scientists at all of these institutions have discovered over 130 papers that have been published now since the 1970s in the secular literature talking about tissue found in dinosaur bones. But it's kind of ignored because the evolutionary story can't explain how that survives that long. So Mary Schweitzer said that's amazing, and she went and published further papers trying to figure out ways in which the tissue might be preserved for millions of years. How can you preserve soft tissue for 65, 70, 100 million years in these bones? Maybe they aren't that old. How about that? Maybe they aren't that old. What do you think there, Luke?
No, I don't think they're that stinking old. I mean, come on. There's a lot of
things. Look at that one there. See, that's pretty cool.
Yeah. Yeah. I mean, yeah, like you said,
right there, you can see where the marrow was right there. Yeah.
Yeah, the marrow that was right there and stuff. What type of bone is this anyhow?
That is a vertebrae. So that came out of the tail of one of these guys, right out at the caudal vertebrae, way out at the end here. And if you take this bone out into the museum, and they have a skeleton of a Triceratops on display, and you walk over there and you look at the tail of the actual skeleton and hold this up, it's exactly the same shape and orientation and proportion as that bone in that skeleton. So, yeah, they positively identified that as a Triceratops vertebrae. That's what I got that I dug myself out of the ground right there.
Huh.
So, yeah.
What was the procedure or whatever of digging these dinosaur bones out of the ground? Did you have to get the dirt out and then brush them off, or?
Exactly. So that's a very good question. So they taught us how to very carefully approach that, and they give you a screwdriver or a pointed object to dig, but you don't stab directly into the soil because you might damage something. You go sideways and you scrape, and then you uncover any hard object and look at the surface, and if you see a shiny, hard surface like that, it might be actually part of a bone. Then you get the brush and start brushing, and you get softer plastic tools so that you don't damage the surface, and you slowly dig around it. And then a lot of work with a paintbrush. Sometimes you use an air gun. Yeah, and then when you take it to the lab, the sediment that's still stuck to it, like sandstone and so on, they have a little blasting box that you can stick your hands in with a jet of air that you can blow off all the little fragments and clean them up. And then you seal it in a PVA or polyvinyl acetone, dip it in there, and it comes out, and it makes a vinyl kind of a plastic coating and seals it from further degradation. So that's the process that I did on this, and that's what's normally done for those kind of fossils.
Interesting. Yeah. So what type of, you mentioned with Tim Clary.
Tim Clary, yeah.
That you were looking at the layers and the strata of the rocks. What all did he say about that?
Okay, let me briefly tell you a little bit about his work. He has published this book, and he's doing volume 2. This is Carved in Stone by Dr. Timothy Clary, and it's subtitled The Geological Evidence for a Worldwide Flood. Okay, so what he's done, his career was to work over 30 years in the oil industry all around the world, and he was an expert at looking at the core samples when they dig a core to explore where they should look for oil. They go down and they dig thousands of feet into the crust of the earth, and then they bring these rocks up and line them up, and you can see the sandstone layers, the limestone, mud, maybe volcanic ash, more sandstone, all the way down thousands of feet. And there are literally thousands of these wells that have been dug. And he, as a research geologist for Chevron Oil and other companies, has access to that database and all around the world. So in his first volume, he covers the continents of North America, South America, and Africa, and a little bit of the Asia area. But he's going to do another book on Asia, Europe, Australia, and Antarctica, and Greenland. I think he covered Greenland. Anyway, what he's looking for is, do these layers represent some kind of sequence, and is that sequence replicated on all the different continents? And the answer, and he said, when I started this research project and looking at these layers, I didn't know whether it was going to support the creation account of a global flood or not. But I just went in on faith and objectively started making the measurements, and I found that the same sequence of layers that you see in the Grand Canyon is repeated up in New England, is repeated in Greenland wells, is repeated down in the south. Sometimes maybe one portion of it might be missing, but they're always in the same order. And some of these layers extend continental, like across from Australia all the way up, into Africa. It's amazing. So what it really shows is, and as the flood of Noah, as described in Genesis, took place, how long do you think it lasted, Luke? How long did the flood last?
Let's see. The waters were rising for 40 days and nights, but before the entire earth was completely uncovered, and when Noah and them could get off the ark, it was over a year.
Exactly. So the old Sunday school story of a little bathtub-like boat with the giraffe's neck sticking out, and Mrs. Noah's washing at the washboard on the side, and the animals are all there. That's kind of a watered-down children version. But what really you had was huge tsunamis, It rained 40 days and 40 nights, but then it says, and then the fountains of the great deep were opened. So the fissures in the middle of the ocean basins and the continental plates, like along the Cascade Range up in Washington and Oregon and Northern California, where all the volcanoes are, you have a subduction of one tectonic plate going under the other. That's happening all over the world. And out in the oceans, you have this subduction that began to bring the ocean basins up and make the water level rise. The mountains had not yet formed. And actually, water came from down in the earth through the fountains of the great deep, along with the lava and magma and hot gases and so on from the core of the earth, all the volcanism, ash clouds. I mean, these huge eruptions they talk about at Yellowstone. The evolutionary time scale would put those at 600,000 years ago, up to 2 million years. And that's based on radiometric dating of the rocks, but there's a lot of assumptions made there that basically is fundamentally an unreliable method. I know that's a hard pill to swallow because, and when I was going to school and studying chemistry and biology, I was kind of thinking, well, science has proven that there are millions of years, so I've got to find some way to make that fit in the Bible. Like each day was an age in creation, or a huge gap of time between Genesis 1:1 and Genesis 1:2, some kind of progressive evolution idea or theistic evolution. And I thought about those things until I started studying ICR and the other creationist materials and saw that, hey, are you going to believe what the Bible says and take the authority of the Word of God? He was there, we were not. Or are you going to take the opinions of man? The founding fathers of science back before Darwin, like Maxwell, Isaac Newton, Faraday, Pascal, Boyle, all of these that came and discovered all the fundamental laws of nature, they were all creationists, most of them Bible-believing Christians. And they did not believe, they believed in the time scale as given in the genealogies in Genesis, putting the creation maybe at roughly 6,000 years, maybe no more than 10,000, but somewhere around 6,000 years ago, and the flood then would be about 4,500 years ago. That would be the explanation for finding soft tissues in these bones. In a bone like this is too hard and dry, but a bone of about this size, if it was intact, you could go and dissolve and maybe even find some soft tissues inside of a leg bone like that. And that's what they've done. Now, and also carbon-14 dating. Let's talk about that. Can I talk about that for a minute?
Oh, yeah.
Okay, so
and radiometric dating.
Yeah, we're going to, okay, the radiometric dating, the other isotope systems such as the strontium, rubidium, and lead argon, and potassium argon is what I meant. The potassium argon is used. What it involves is a radioactive isotope that is slowly decaying over time, and the assumption that's made is that the rate that it's decaying stays constant over large time, okay? So let's say the carbon-14 is a fairly short half-life, and it's really not used for rocks. Mm-hmm. Because it doesn't have a long enough half-life to measure. It's used,
that's what they think.
Yeah, it's used. That's right. It's used for what was once alive, so plant material or parts of an animal. Okay, yeah. Wood, bone, whatever. What you do is there's a carbon-14 is a radioactive element that's in the atmosphere, and it's ingested by living things, and it becomes part of our body. But that carbon-14 is decaying to nitrogen, and the half-life of it, which means half of the quantity that's present, will dissipate and change to nitrogen in a period of about 5,730 years. So it's about 5,700 years, roughly. So in 5,700 years, only half of it's left, and then in another 5,000 years, only half of that, or a quarter of the original, is left. And then another 5,700 years, an eighth, a 16th, a 32nd. It's going to go by power 2 every. So by the time you get up to 50,000 years to 100,000 years, there isn't any measurable carbon-14 left. So, and to be generous, 100,000 years would be the absolute maximum. It's all gone. Okay. So you shouldn't expect to find carbon-14 in these bones, but they do. And they find carbon-14 in carbon, in coal deposits, which are said to be millions of years. They can make coal in the lab under pressure in a short period of time. They find carbon-14 even in diamonds. It's hard to get the labs to do the analysis because they assume from the naturalistic paradigm they're not going to find it, so it's a waste of time. So, but the carbon-14. Now, the other radiometric dating that you referred to. Let's take the argon lead or the potassium argon. That's got a half-life of some hundreds of thousands of years. Okay, so the assumptions that, and you can measure the ratio. I worked in the mass spectrometry field for 38 years as a scientist, and my company made these isotope ratio instruments in Europe. You can measure very accurately in a sample the ratio of the radioactive potassium isotope to the argon, and you can get a signal for that, and you can get that ratio to like less than 0.1% in the best cases. Yeah, so they will say, well, we know the age of this rock within 1%. Well, what you really know is that you measured the ratio of the isotopes to within 1% precision, right? But that doesn't give you an age. Now, the assumptions are that no daughter ion or product ion was present when the rock solidified and was formed. You didn't have any argon in there. So whatever argon you measure in the rock, you assume came from the decay of the potassium. You assume that no potassium was washed out by hot water coming through the rocks, or nothing was added in the environment. You don't know for millions of years what's happening to that environment. The best example I can say for the questionability of those methods is numerous creation scientists have taken samples of recent volcanic eruptions where igneous rocks were formed, say within 20, 30, 40 years. Say at Mount St. Helens in the 1980 eruption, the lava dome began to form, and that lava was molten and it solidified. So they know that when they went back in 2000, they knew that was 20 years old. They take a sample and go to the lab, and they get 250,000 years, or numbers up in the hundreds of thousands or even millions of years, and it's all over the map. Okay, Mount Pinatubo, I believe, is in the Philippines. Same thing, that they knew when these eruptions occurred. They get these ridiculously large ages for these young rocks because of the assumptions in these methods. Okay, there is a plateau called the Uinkaret Plateau on the north slope of the Grand Canyon, where volcanoes are in this whole fault line there, and the lava erupted out of these cinder cones and ran over and down the edge of the canyon down to the basal rocks way down at the bottom. So they dated the basal basalt, which is almost like the pre-flood rock, and then they dated the lava that flowed down, and they got ages that were about the same. They got ages up in the hundreds of thousands of years. Okay, millions of years. And the Indians saw those eruptions. We know that they're historically, there were eyewitnesses to that. So the young rocks give erroneously large ages in many cases, and even the evolutionary geologists that have done that research have sometimes admitted that, well, if they get numbers that are way out of whack, they pick the one that's closest to what they know is true because they know that's the way it happened. So it's kind of like there's a lot of kind of cherry picking that goes on.
Of course, by what they know is true is more of a, this rock is probably this far down. So, okay, this should be, it's in this layer, so it should be this old. But what on earth? It's a wacky number, so now that can't be true, so they chuck the number out, even though that part is a part of the science, a part of the evidence. You should leave it right there with all of the other numbers that you got, even though, because that is what you observed. Do your observations, leave them all there. But anyways,
Yeah, let me add to that a little bit of a story that fits what you're just describing there. There's a circular reasoning involved in this age determination. So, and they will pick and choose the numbers that support the theory. They will say, well, how do you know how old this fossil is that was found in that layer where I dug it out right there? Well, there's a volcanic ash layer above and below that. And that was igneous rock. So we do a radiometric dating on those volcanic ash, and we come up with 90 million years. So we know that this rock is in between there. So it must be about 90 million years old. Okay. Now, what they may not tell you is that they did 5 or 6 radiometric dating samples in those layers, and they came up with ages from 10 million to 250 million, but they like the 90 million one, and that's maybe the average or something. That's what fits the story. So that's what so that rock is, that fossil, since it is dated by the rock layers that it was found next to, the igneous rocks, okay? Well, okay. Then on another site, they'll say, okay, so we know this type of fossil is a dinosaur vertebrae, and anything this is at least 65, 70 million years old, okay? So then that becomes an index fossil that we can go look in other layers, and we're looking at what's the age of this rock? Well, it's next to one of these index fossils that we know is about 65, 70 million years old. Therefore, that rock is that old. So we date the fossils by the rocks, and then we date the rocks by the fossils. You see, it's kind of a
circular reasoning.
Yeah.
So certainly wacky for them to do that, because come on, one of them, if you're going to do that, one of them has to have a specific age, right?
Yep.
If the whole thing even worked, of it being millions of years old. But still, one of them has to be, I don't know, like they've got to one of them has to have a specific age that you absolutely know. You can't just circle around like that.
There has to be some standard, And God was there, and he described the process of creation and of the flood. Man was not there, so we're doing historical science. We're looking like forensic science. We're looking at evidence that's left of things that happened in the distant past. We don't have the ability to take that into the lab and do experiments that are repeatable, or to do the scientific method where you test a hypothesis in the laboratory. Historical science doesn't do that. Historical science creates a story that tries to explain the best way to understand how that formed. But that is going to be filtered through the worldview that I have. If I approach it totally naturalistically, and I say I'm not going to let any supernatural influence come into this, then I'm going to come up with an answer that fits that paradigm. One famous evolutionist said, things have the appearance of being designed, but we know they aren't, and we can't, even though they look designed, we can't let a divine foot in the door. So we are restricting all the explanations to totally materialistic, naturalistic process. That is the secular paradigm. As creationists, we approach it from the biblical perspective and say, science is going to confirm the Bible. We don't use science to try to twist the Bible. We don't force the science into the Bible. We take what God's Word says, and then we see how the evidence fits that, and we find then that science confirms the Bible. Let me back up, if I have a minute, to also talk about, I've talked about the dinosaur dig. I've talked a little bit about what we did, about the bones. We've talked about the dating processes. We've talked about the layers and so on. We see sedimentary layers in the canyons that were formed quickly after the Mount St. Helens eruption, where there's fine layering on these 30, 40, 50-foot precipices, that created in just a matter of days. So, let me talk about dinosaurs in the Bible, okay? Maybe we can sum it up with that. So, one question that's often asked, well, why aren't dinosaurs in the Bible? Well, the word dinosaur was not invented until 1841 by a paleontologist who coined that phrase when they started finding fossil bones in the 1840s. The King James English Bible was translated in 1611, and that word did not exist. But they did use the word dragon. Mm-hmm. Now, there are dragon legends in just about every culture around the world. There are King George slaying the dragon. There is explorers, Alexander the Great, and other explorers have stories of encountering large creatures. The native that inhabit the Congo talk about Wakili Mamumbe, which is kind of a creature. When they showed him a picture, that's him. Huh. And they claim that they're still around out there. But you have carvings on cave walls. You have at the Angkor Wat Temple is 800 A.D. Down in Cambodia. There are on this whole temple complex there are carvings of all different animals. And here in one place you'll find a stegosaur carved there. You can see the little head and even the spikes on the tail. That means somebody saw that.
Yeah.
In recorded history, that these things were still around. The thunderbirds that the North American Indians up in the South Dakota Black Hills talk about. And there's legends talk about big birds coming and landing up there, and maybe they were like these not plesiosaurs or what, the flying reptiles.
Pterodactyls.
That's the word I'm looking for. Yeah, exactly. So what we have in the Bible, in the book of Job, and I think maybe one other place, but take Job chapter 40, talks about two creatures. Job, at the end of that book, God is explaining to him, were you there when I created all these things? When I set the earth in motion? Let's think about the behemoth. This creature that I made alongside of you, which means he's there coexisting with man, right?
Yeah.
And his legs are like the cedar, and his tail is like a cedar. His legs are like pillars, and his plates, are covering him and everything. And basically, this huge, strong animal that it sounds like a dinosaur,
Yeah.
And then for sea monsters, you have the Leviathan, which had plates on its back that were interlocked. You can't even get a knife in between, and this huge sea monster that just went around eating everything,
Yeah.
So the stories of sailors seeing sea monsters are all there. There's stories of there's a at Carlisle Cathedral up in England. There's a tomb of a bishop that died way back hundreds of years ago, and on the floor right there at his memorial and carved in brass is two of these kind of sauropod-looking creatures with long necks and long tails intertwined. And any child would look at that and say, "Well, that's a brontosaurus," Yeah, and there's a lot of stories like that. And ICR, Answers in Genesis, Creation Ministries, they all have books and a lot of resources that explain all this. There's one called Dragons and Dinosaurs that talks about all these myths and so on. There are flood myths from all different cultures that talk about a boat that saved people from the water. And even in the Chinese culture, some of the characters for these words have references to the story of Noah and his family. It's fascinating. So there are dinosaurs in the Bible. Now, some of the modern translations say, well, maybe it was a hippopotamus. Yeah, does a hippopotamus have a tail like that? Or an elephant, like a cedar. I think that there's a lot of influence from the secular community and the academic environment, since they all are speaking with an authoritative voice all around the world, in the Western world, to knuckle under and cave in on these things. And you're swimming upstream, but when you say, okay, let's go back and look at this from the biblical perspective. But as a scientist, if you open your eyes and look at the evidence, from a biblical perspective, you will see that, in fact, science does confirm the Bible. That's where I'm going to end this. Science confirms the Bible.
Yeah. So, well, thank you for this. I think if it's all right with you, our audience here might have a few questions.
That's fine.
Through it, so I'll maybe hand the mic to some of them if y'all got any questions.
Oh, that'd be fine. Get on board the ark, man. The flood is coming. Come on, get on board.
All right, that was fantastic. But I've got a question. So the evolutionists say that the geological column goes from very simple life forms to very complex, and the layers are very well defined. And so how would you explain that from a creationist perspective?
Rather than being in the order of deep time or long periods of time from the simplest to the more complex, we believe that during the flood, the process of burial of the sediments progressed as the flood waters rose and washed on and off of the continents. So what you had was the sediments coming off of the land, burying first the marine life that lived on the surface of the ocean, and then the animals that lived along the coastlines would be next. And then as you go up to the continental shelf, you'd get different kinds of animals and plants. And then up at the highest region is usually where the mammals and humans would live and so on. So that would be the last. And the life forms that existed in the pre-flood world probably were quite a bit different than what we have now. There were large areas on the land where you didn't have tall mountains, but you had lots of really lush vegetation and tropical kind of conditions where the dinosaurs and other creatures lived, and so those would be washed in and buried as in certain layers. So it's more of an ecological zonation instead of a deep time kind of column.
I see. Cool. So the animals that could run faster could get to higher ground.
Exactly, and probably the dinosaurs were running and swimming, and mammals, were the ones that went to higher ground. And then as the flood progressed and it reached the highest stages where it covered all the hills and the whole earth, then after that, the mountains began to rise, and the sea floors were still moving. The continental plates were moving. Probably the catastrophic plate tectonics model that some creationists have proposed is I think, the best. And that would say that the actual continental plates were moving at miles per hour instead of just centimeters per year.
Wow.
During that 1 year of the flood, that they were that's when the Pangea of one kind of continental landmass in the pre-flood world was separating into the continents, and things were moving all around the globe. The cracks in the earth crust were opening. Lava and eruptions were coming through, water, steam, lots of volcanism, volcanic ash, filling the sky with particles that block the sun, and creating a lot of heat to warm the water. So that would create a lot of precipitation and cooling. So that explains also how there could be one significant ice age at the end of the flood for some period of time after the flood, maybe 100 years, 200 years.
Yeah. Oh, that's fascinating. Thank you so much.